All right, we're gonna work several of these mole calculation problems. So I'm gonna show you how to do these. Um, Now, the first ones that we're gonna take a look at are just how to find the molar mass of a substance. And just a reminder, so 1 mole of a substance represents 6.02 times 10 to the 23rd particles. So it's like a very large dozen. Okay, so if I say that I have 1 mole of something, then that means I have 6.02 times 10 to the 23rd of that thing. So when we calculate the molar mass of a substance and we're doing it for an element, we just look at the mass on the periodic table and that represents 1 mole of that substance. If we're doing it for a compound like we have listed right here, then what we're going to do is take the number of each one of those elements, and we are going to find the molar mass for each one of those elements, and we're going to add all of them together. So in this first one, we have sodium hydroxide. If you look on the periodic table, the mass of sodium hydroxide is 22.990 grams. We have oxygen. Oxygen's mass on the periodic table is 15.999 grams. And then we have hydrogen, which is 1.008 grams. And there's only one of each. So if we add all three of those together, we will end up with the molar mass. So 22.990 plus 15.999 plus 1.008, that's going to give us 39.997. Okay, and actually I'm going to round this off to just 40.0 grams and just keep one decimal place in this case. Okay, so that's how you would do that for sodium hydroxide. I'll do one more example. For hydrogen, okay, I have 3 hydrogens. So if I take the mass of hydrogen, which is 1.008, and I multiply it by 3, that's going to give me 3.024 grams. I only have 1 phosphorus, so I just take the mass straight off the periodic table, 30.974 grams. And then if I have 4 oxygens, that's going to be 4 times 15.999, and that would give me 63.996 grams for the oxygen. And then I just add all 3 of those together. So the 63.996 plus 30.974 plus 3.024, and that would give me a molar mass of 98.0 grams overall. Okay, so that's how we would find the molar mass of each one of these compounds. Now, moving down into here, okay, we're going to be using our dimensional analysis, if you remember that from way back. So we're going to take a look at several of these examples. Now, number 1 and 2 have actually been done for you, so you can go back and look at these. Like number 1, how many moles are in 15 grams of lithium? So if you take 15 grams, set it up, okay, where you have your conversion factor here, where 1 mole of that substance weighs 6.94 grams, because 6.94 is the mass off the periodic table, then you can find that you'll end up with 2.2 moles of lithium. Now, number 3 right here, you have 22 grams of argon, okay? And if we know the molar mass of argon by looking at the periodic table, it's 39.948. And then that is equal to 1 mole of argon. Okay, so these two things are equal. 1 mole of argon equals 39.948, because that's the mass on the periodic table. So we take 22, divide it by 39.948, and that's going to give us 0.55 moles of argon. okay? And that is our final answer, all right? Now, you can also go the other direction. So, like this one right here, it's giving you 88.1 moles of magnesium and asking you how many grams that is. So you would just start with 88.1 moles. You'd have 1 mole on the bottom and then put your molar mass of magnesium on top. And then that would be your setup for your calculation, okay? Let's go ahead and take a look at 1 or 2 on the back where you actually have compounds that you're calculating for. So let's look at number 11. Number 9 and 10 have actually been done for you, so you can look at those as examples. But first off, we need to calculate the molar mass of beryllium iodide, BeI2. So beryllium iodide, so beryllium has a mass of 9.012, and there's only one of them, so we don't have to multiply it by anything. And then iodine has a mass of 126.904, but there's 2 of those, so we got to multiply that number by 2. So that's going to be 253.808 grams. And then if we add those together, what we end up with is 262.8 grams. So that's the molar mass of beryllium iodide. All right, next, when we set up our dimensional analysis, we're going to have 0.02 moles of beryllium iodide. Okay, now, the mass of beryllium iodide is going to be 262.8. Again, we want diagonal units to be the same. So if you remember back from when we did dimensional analysis, we want this to be 1 mole of beryllium iodide, and then this to be 262.8 grams of beryllium iodide. And when you multiply those together, 0.02 times 262.8, you're going to end up with 5.3 grams of beryllium iodide. Okay, and that's the mass of beryllium iodide if you have 0.02 moles of beryllium iodide. All right, if you guys have any questions at all, please reach out and ask. But there's several examples for you to go off of for this paper. Okay, hope you guys have a great day.